Thinking about an antenna for the 6-meter band, I thought I have already a wire from here to here in the garden for the 17-meter band. If I make it with some lines, you can see how it is done, and the coax cable is going to the window. So I thought maybe I can make in parallel another antenna. The feed is like this, so it is not complicated. This is the one side of the dipole, and this is the other side of the dipole, and the dipole is sloping, so it has some directional preference in that direction. I didn't use any balun or RF choke, just connected the cable to it, and a few meters further inside I connected transceiver, but this is for the 17 meter band, and I connect now some wires from here and some wire from here as an additional dipole. So this red-white wire is the 17 meter band dipole, and I added 2 wires like this and this, and they just hang under the 17 meter dipole with some spacings. From below it looks a bit messy, also because I did not stretch the wires that I used, but this is 1.5 meter and this is 1.5 meter, and I used here and here plastic spacers, and I hang the cable through it, the wire through it, so I could easily cut it on length to get it into resonance. This is the final result seen from above, out of the window. The spacers, the insulators are at the end now, and they hang neatly here below the 17 meter band dipole. So I have 2 dipoles now on one coax cable, simulated with Manna, the simulation program. This is the 17 meter band dipole, and I could not identify any difference when the 6 meter dipole is added. Because it is sloping, it has a preferred direction into that direction, the one that is sloping. You can see it here. This is the dipole with the 6 meter band dipole, and in fact it is this direction, and to be honest even more sidewards. Let's see what happens if I simulate the 6 meter dipole. For the 50 megahertz sloping dipole, you see about the same as with the 17 meter band dipole. It is a bit higher in wavelength because it is all at 7, the center FET is at 7 meters high. But when we combine them, you see that it is completely different than what you would expect. It looks like this, into several directions, a lot to straight upwards. But if we look at the 3D simulation, it will become more clear that you at least radiates in all directions, but with different angles, and indeed a lot to the top. So at least you radiates, but it is more around then into a specific direction. Looking at the current distribution when we have the long dipole for the 17 meter band and the shorter dipole in parallel for the 6 meter band, you see that this one has a normal current distribution, but it also has a current in the large dipole that was not our intention, but it influenced, of course, the radiation pattern of the total array. So this is to keep in mind when you connect dipoles in parallel, what could happen. With this setup on the 6 meter band, I worked a lot of sporadic E and also a double hop and triple hop sporadic E. So at least you have an antenna that functions, but it is good to be aware what happens. That's for this time. Next time another antenna that I used for the 6 meter band.